Find the function graph's end behavior. So here's the first function, y equals negative 3x to the third power plus 2x to the second power plus 5x minus 6. Okay, so again, what they're talking about is a graph. You don't need to draw this, but that's x positive infinity, that's x negative infinity. Now when I'm asking what y does, that's on what y is the function. Okay, y is the function of x. Okay, so this side depends on the leading coefficient. The leading coefficient is negative 3, so then therefore it would go negative infinity. Okay, the degree. The degree is 3, that's a third power, not written very well. And that's an odd degree, so if they're odd, the end behaviors have to be opposite. Okay, so negative infinity, you would have positive infinity. Y equals 5x to the fifth power minus 4x to the third power plus 6. Leading coefficient is this 5 right there, and it's positive, so it will be positive infinity there, and the degree is 5. And if that's an odd, I don't care if the degree is positive or negative, I care if it's even or odd. It's odd, so the end behaviors would again have to be the opposite. Okay, so that's positive infinity, this side would be negative infinity. Okay, y equals negative 2x to the sixth power plus 4x to the second power plus 8. So leading coefficient is negative 2, and the degree, or negative 2 tells me that that's negative infinity. And the degree is 6. Okay, that's even. So an even degree means the end behaviors have to be the same. So negative infinity, negative infinity. Okay, write a polynomial function with the given roots. Only real rational values can appear in the final equation. So all these are real, they're all rational. There's no i's, there's no radicals. So y equals x minus 2. X minus 7, x minus, but if it's negative 6, it'll go plus 6, okay? Okay, number 5, 2i and the square root of 2. Now, these come in pairs. Radicals and I solutions come in pairs, so we're also going to have negative 2i, and we're also going to have negative square root 2. Okay, so that's 4 solutions. Or 4 roots. X plus 2i, x minus 2i, x plus the square root of 2, and x minus the square root of 2. Now your i's and square roots need to be simplified. Those products need to be found. Okay. So I think FOIL, but I know that you don't have to find the middle two products because they just cancel out. So x times x, and then 2i times negative 2i. So it's x to the second. That's going to be negative 4i to the second, but I to the second is equal to negative 1, so negative 4 times negative 1 is 4. Now it's positive 4. So we write that as x squared plus 4. Okay, x times x, and then the square root of 2 times a negative square root of 2. Okay, so x times x, x to the second, positive times negative is negative. And then that would be the square root of 4, but the square root of 4 is equal to 2. Okay. The negative stays. We don't do the I because the negative is outside of the square root. Okay, so it's x squared minus 2. That's as simplified as I need it. Okay, 7, 3i square root of 5. So the 7 is not it's not an I, it's not a radical. This is I, so it'd have negative 3i. That's a radical, so it'd be negative radical 5. So y equals, we'd have x minus and then 7, and then x plus 3i, x minus 3i, x plus the square root of 5, x minus the square root of 5. Okay, so we need to find these products here. Okay, so x times x, and then 3i times negative 3i. So it's x squared, and that'd be negative 9i to the second, but then it's negative 9 times negative 1, and that's 9, positive 9. So x squared plus 9. Okay. Square root of 5 times negative square root of 5. Okay, positive times a negative is a negative. Square root of 25, so square root of 25 is 5. Okay. That's a negative 5, so it's x squared minus 5. There we have it. Okay, now we're going to find the solutions to the equations by factoring. So we have 3x to the third power minus 11x to the second power plus 6x. Okay. So there are three solutions, or three roots, 3 x-intercepts, or not, maybe not 3 x-intercepts, but roots and solution is what you're thinking. Okay, so it's got to be equal to 0 because you see we have x to the third, x to the second, and x. There's no constant. The 0 doesn't count as anything, okay? So that's 3 terms. So 3 terms. So GCF and the t-table. Then we'll want to do a DOPS check over here once we're done. Okay, so how do I check for GCF? Do we have a variable on the last term? We do x. Do you have a negative on the first term? No, you don't. 3, 11, and 6 would just be in the first row on that multiplication table. So I put 1x here. And I factor out 1x. And so means I go divide by it. 3 divided by 1 is 3. 3 minus 1 is 2. That'd be x second. 2 minus 1 is 1, so that's x to the first, and plus 6. Those cancel. Okay, so I'm going to cross that out so we're not looking at it, because this is where I'm going. This parentheses here is the trinomial I need to factor. So a, b, c. 3 times 6 is 18, positive. So the signs have to match. They have to add to negative 11, so they would both be negative. So 1 and 18, no. 2 and 9, yes. So A is 3x to the second. Again, I always make 4 parentheses. And if the leading coefficient is 3, we start with a 3 and a 3. Then we break the x down into x. If it's x to the fourth, it'd go x squared. You keep the leading coefficient, you put that first in each parentheses. It's known as the Berry method of factoring. Okay, it's the guy who made it up. X, then minus 2, minus 9. Now we're thinking 3 and 2 don't have any common factors other than 1. 3 and 9 can be reduced by 3. So that would be 1x or x minus 3. So I bring those two factors over here. Okay, get rid of the 1 there. That's a minus, but those are not perfect squares, so that's just brought down. That's a minus. Those are not perfect squares, so that can just be brought down. And there's your factorization. Okay, you're going to get one solution from each one of these parentheses, and that will make your 3. So 1x could equal 0. So 0. 3x minus 2 could equal 0. I'd add 2. And then we divide by 3. That's a decimal, so I'm going to put 2/3. And then x minus 3 could equal 0. So x would equal 3. Okay, number 8. X to the 4th power minus 14x to the 2nd power minus 16 equals 0. So there's 4 roots. Because we have x to the 4th. We don't have x to the 3rd. We have x to the 2nd, then the constant. Okay. So that's 3 terms. 1, 2, 3. So it's a trinomial, so GCF and the table. Then Dobbs check over here. So x on that, nope. Negative on that, nope. 1, 14, and 16 would just be 1. Okay. One times negative 16 is negative 16. Okay, so it's a positive times a negative, and it's got to add to negative 14. I don't think I have this right. Okay, so I know I don't. I got to change this. Just give me a second. I got to change this problem. That needs to be a 15 instead of a 14. Okay. Okay, so it's got to add to negative 15. So that does it. Okay. Okay, now A is 1x to the 4th. Okay, so I map out my 4. Okay, if it's a 1, you can just get rid of it. X to the 4th has to be go to x squared. Okay. Plus 1 minus 16. Okay, those can't be reduced because the coefficient's just 1. Okay, Dobbs. X squared plus 1, x squared minus 16. Well, I know the plus cannot be broken down. The minus can, because you got x times x and you got 4 times 4. Okay, so that would go down. x4, x4, so you got plus, and then minus would stay the same. Okay, now 2 of the solutions come from there because we still have x to the 2nd, 1 from here, 1 from here. So x squared plus 1 equals 0. X squared would equal negative 1. Apply your square root. Extract the I. Okay. So x could be a positive or a negative 1i. Okay. The square root of 1 is 1. So I can drop the square root. 1i, negative 1i. Okay. Then x plus 4 could equal 0. X would equal negative 4. X minus 4 could equal 0. And x would be positive 4. Okay. Okay. Next problem. X to the 3rd power minus 2x to the 2nd power minus 9x plus 18 equals 0. Okay, so we have 3 roots because we have an x to the 3rd. We've also got an x to the 2nd. We've also got an x, and we've got a constant. So that makes 4 terms. Okay, so 4 terms, 1, 2, 3, 4. Okay, 4 terms is the grouping method. Parentheses plus parentheses, line parentheses plus line parentheses, then the little parentheses and the big parentheses. And then we'll have to do a dots check over there, difference of perfect squares. So we have 1x to the third minus 2x to the second, negative 9x plus 18. X second on the last term. All right, so x second you're not going to have a negative. 1 and 2 is 1. Okay? So we'll divide by 1x second here in a moment. No, x, we do have a negative, and then 9 and 18 would be 9. Okay? So it's going to be 1x to the first, or x minus 2. 1x minus 2. So in each parentheses we have 1x minus 2. And we have 1x second and negative 9. Okay, so dots. Take those 1s off, you don't need them. That has a minus, but the x doesn't have a power, so that gets dropped. This has a minus, and we have x to the second, which is a perfect square because it's x times x. 9's a perfect square because it's 3 times 3. Plus minus, so x3, x3. So the plus is dropped, and then the minus is not a perfect square, so it's x minus 3. Okay, so I get one solution from each of these, because they're all x to the first. X minus 2 equals 0. So x would equal 2. X plus 3 equals 0. So x would equal negative 3. X minus 3 equals 0. And x would equal 3, positive 3. Okay, now number 10 says refer to the solution set for problem number 8. Now I need to change that to a 15. So let's go back and look at the roots we got on problem number 8. 1i, negative 4i, negative 4 and 4. Now the x-intercepts are the solutions, but the ones that don't have the I. Okay, so it's just these that I bring over here. In the y-intercept, we simply set our x equal to 0, which would take out all of our x's, and y would equal negative 16. Okay, that'd be where it crossed the y. It'd be a roller coaster graph. It would cross the x and x-axis at negative 4 and 4, and it would cross the y-axis at negative 16. Okay, find the quotient. We have x to the third power minus 14x to the second plus 51x minus 54. Okay, that's the dividend. Divided by the expression x plus 2. That's the divisor. Okay, so we need to set up our synthetic division. Okay, so the dividend, we just put the coefficients 1, negative 14, positive 51, negative 54. And the divisor x plus 2, we set that equal to 0 and find what that would be. It'd be negative 2. Okay, so I would drop my 1. 1 times negative 2 is negative 2. And I add to negative 14. Negative 14 plus negative 2 is negative 16. Negative 16 times negative 2 is 32. So 51 plus 32 is 83. 83 times negative 2 is negative 166. Now obviously I get a pretty high remainder, and that's okay. Negative 200 r negative 220. Now write this out. So the 1 used to be x third, but now it's 1x squared. Minus 16x plus constant 83 plus the remainder negative 220. You underline that and you put the divisor expression x plus 2 under it. Okay. There's your quotient. Means this is not really a factor of this because you got a remainder. Okay, number 12, x to the third power plus 7x to the second power minus 38x minus 240 divided by x plus 5. Okay, so the dividend and the divisor. So 1, 7, negative 38, negative 240. And then x plus 5. And we get negative 5. One times negative 5 is negative 5. 7 plus negative 5 is 2. 2 times negative 5 is negative 10. And you get negative 48. Negative 48 times negative 5. Got positive 240, so that's going to be a remainder of 0. Okay? So 1 used to be x third, now it's x second, plus 2x minus 48. If the remainder is 0, we just leave it, and that's what we have. You don't need to solve it. Okay, I know you could, but we don't need to. Okay, that means this times this ends up being this exact product. And I get a remainder of 0 like that. Use the rational roots theorem to find the solution to the following equation: x to the third power minus x to the second power minus 3x minus 9 equals 0. So, we need to find the roots. There's 3 of them, and it flat out says use the RRT. And then we're going to need this. You should set that up and that up before you do anything else. You know you're going to need both of them. Okay, right there. The final 2 answers we will find by factoring, because I will get it down from an x third to an x second degree equation. This right here, you will apply the RRT to find that answer. Okay, so RRT, you got to remember how to do that. You take your constant at the end. It doesn't matter if it's negative or positive. In the numerator, your leading coefficient in the denominator. So factors of 9, 1, 9, 2 is a decimal, then I get twin factors. As soon as I get twin factors, we have them all. Either twin factors or dividing by a number that you've already done. Okay, that it's already on your chart. So 1 divided by 1 is 1, 9, and 3. All positive, negative. Okay. So when I start plugging them into the equation, I got to get 0. One is not it. 3. There's 0. So we have our first answer and the answer we're going to divide by. So we have 1, negative 1, negative 3, negative 9. So 1 times 3 is 3. Negative 1 plus 3 is 2. 2 times 3 is 6. 3. And then 3 times 3 is 9. Okay, so there's your remainder, 0. Now our new equation, it goes from an x third to an x second. So we have 1x to the second plus 2x plus 3 equals 0. And now I've got x squared. I've got x and I got a constant. Well, now it's 3 terms where I can use my factoring properties. Okay, GCF. No negative there, no x there, no negative, just be 1. Okay. 1 times 3 is 3, positive. Add to positive 2. Okay. Little problem here. 1 and 3 adds up to 4, and then 2 is a decimal, then I'm just back to 3. So you put QF, that is a prime expression, so you use your quadratic formula. Opposite of B, plus or minus B square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So opposite of 2 is negative 2. Okay, that's going to be 1. 2 times 1 is 2. So I know I've got negative 2 plus or minus over 2. And then my square root, B, is 2. A is 1, C is 3. So I go to my calculator, second square root, double the parentheses, 2 to the second, minus 4, 1, and 3. Okay, if I get a domain error, and this is right, I do get a domain error, I make a square root, and I just plug the same thing in, but I don't hit the square root button. The square root's going to stay there. Okay, now I'm just not going to hit the square root. Okay, you got negative 8. Okay, going to need to poke the I out. Now you could simplify that into square root of 4, square root of 2. You can just put that, that's fine. That's what most people will do. And I would be perfectly okay with that, because you can't add and subtract. Or you could break down your square root of 8, okay? Because it's divisible by the perfect square of 4 to get 2. The I would be between them. So you'd have negative 2, 2I square root of 2, and then 2. Okay? Then negative 2 divided by 2 is actually negative 1 plus or minus. And then 2I divided by 2 is 1I. The square root doesn't get divided. Okay? And then you can write that, but I'm fine with if you just go that route. Okay? And then you write the same thing. You don't have to do this. Give me to that, and I'll be thrilled. Okay, use properties of exponents to simplify the expression. So we have a parentheses. We have 3x to the third power to the second power times x to the fourth power. Okay. So what are your operations? Well, you got times, then an exponent, and then another time. So it's all times. So we have a factor of 3, a factor of x, and another factor of x, so we're just going to write plus. Okay, 1 times 2 is 2. Then there's x, 3 times 2 is 6, and then 4. 6 plus 4 is 10. These are both positive, so they both stay in their same position. And 3 to the second simplifies. 3 times 3 equals 9. So this is 9. So it's 9 times x to the 10th. And you can't multiply anything else. Okay, next one we have parentheses. We have 2 to the negative second power, x to the third power, y to the negative second, and negative 4. So we got times, times. So again, it's all multiplication. So so you have 2 times x times y. So negative 2 times negative 4 is positive 8. 3 times negative 4 is negative 12. And then negative 2 times negative 4 is positive 8. So that would stay in the same position. This needs to change positions so that it can be x to the regular 12. And that stays in the same position. Okay. I can simplify that. I'm just going to use my caret key. I don't really want to write out 8 2's, 256. So you have 256 times y to the 8th over x to the 12th. Okay, number 16. 4x to the 9th power, y to the 3rd power, divided by x to the 12th power, y to the 2nd power. So the operations you got is times, 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 all times. Okay. Now on top I've got 4x and y. 4 is to the 1st, x is to the 9th, y is to the 3rd. They're not in parentheses, so we don't need to distribute. Then on bottom I've got x times y, and a 12 and a 2. So I can cancel x's, but I'm going to cancel this one because that's where the smaller one, and it was a 9, so I take 12 minus 9, and that's 3. 3 and 2. Minus 2, 3 minus 2 is 1. Okay, so all these are positives, so they stay where they're at, all of them. Then 4 to the first is 4. Okay, and then the last problem. A company's profit can be modeled by the equation P equals x to the third minus 7x to the second plus 14x. X represents the number of records sold in millions. P represents the profit in millions. The company currently produces 3 million records and makes a $6 million profit. What other numbers of records can reach the same profit? Okay. So I'm given the equation. I don't need to generate the equation. It was given to me in the problem. I got to determine what these variables represent, P and X. So P is our profit, X is our records. So we know that 3 million records, just use 3 because it's in millions, so you can just go with 3, and a $6 million profit. Now put those in the equation for the respective variables. So 6, 3, 3, 3. So we have 6. I'm going to put a 1 there. We're going to need 1 later on. 3 to the second minus 7, 3 to the second, or 3 to the third, my bad, that's a third, plus 14, and then 3. Okay. So I plug that expression into the calculator and make sure that it equals 6. Yep, it does. So we want to keep the profit at 6, but we want to find out other x values. That can give me my profit of 6, okay? So it's x to the third, okay? So there are 3 of them, and we already know 2 of them, okay? We already know 1 of them. We already know 1 of them's 3, okay? So if I'm first off, you got to move the 6 over because you have all the x's to all these different powers, 3, 2, 1. If your variable is to multiple powers, you're going to have to move everything over before you decide your next step. Now, I could group, but why don't I just synthetically, why don't I use the L instead, because I know I already have my answer of 3. I don't need to apply the RRT because I've already got 3. So 1, negative 7, 14, negative 6. So I pull down my 1. 1 times 3 is 3. And negative 4. Negative 4 times 3 is negative 12. And then we're at 2. 2 times 3 is 6. Okay. So now I have 1x to the second minus 4x plus 2 equals 0. And now I can apply my factoring properties. Okay, GCF. No x, no negative, and that's just 1. 1 times 2 is 2, positive. So negative, negative. It has to add to negative 4. Well, 1 and 2 adds up to negative 3. That's close, but that's not good enough, okay? So I have to go to the QF. There are no other factors of 2. So opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. So opposite of negative 4 is 4, and then A is 1, okay. So we know we got a 4, a 2, now B is negative 4, A is 1, C is 2. Plug the square root in. Remember, if you get a domain error, that's not the end of the world. Okay. I did not get, I got 2.83. Okay. Now I simplify it. Remember to click equals after you add, divide by 2, we get 3.42. 4 minus 2.83 divided by 2 is 0.59. Those are all positive, so they're all legit. So records, put mil, and then just put records outside. So that's how many records you could sell to reach a $6 million profit, approximately.